The main challenge that we have just now is that over the last 80 years, we may have used up more than half of our petrochemical resources that took several hundred million years to generate. Annually, it's estimated about 1.3 billion tons of biomass are required to replace, let's say, 1/3 of the petroleum resources that we currently utilize.
We're developing a new concept for a biomass economy. We will have units that will convert the biomass into crude bio-oil, and then we're going to ship to refineries to produce chemicals and also transportation fuels.
Our plan is to replace industrial plants on the Texas Gulf Coast with crop plants in the fields of Washington and other areas of the states.
Most of our research revolves around the development of new materials that are produced from different renewable resources. Those could be wood or straw, materials that are purposely grown for fiber, like jute and kenaf. We also work in the area of biopolymers that can be produced by bacteria or harvested from different types of plants.
We have a number of different projects to investigate modifying the fatty acid composition of plant oils to substitute for petroleum products.
Products such as paints and resins and plasticizers. It can be even used as a biofuel additive. It can be used to make nylon.
Energy generation and conservation are some of the key technological problems of the 21st century.
We could generate clean drinking water from seawater if we had a low-cost energy source available. I believe that nanotechnology and advanced materials can make significant inroads into developing low-cost, abundant sources of energy.
Energy is really what makes our society move and to go forward.
From a social problem perspective, my interest is in looking at how people think about consuming resources, sharing those resources, especially when there is a real danger that this resource could be exhausted.
Nuclear energy is one option that could produce significantly more energy and at the same time do it in a way that does not produce carbon. The chemistry of separations allows us to recycle uranium. If we close the fuel cycle and we recycle the uranium, then we also reduce the volume of waste.
If the answers to our problems today were within our individual disciplines, they'd be solved already. But they're not. They sit in between these disciplines.
One of the hallmarks of WSU is that it is at once very open to cross-department, cross-program collaboration and encouraging of that.
It's collaboration. It's the edges of people's intellect. It's the edges of where two disciplines come together, where innovation is spawned.